Because they
didn't work for us.
What, 2 and 5?
No, 25. President died.
Oh, shit. Alright.
Wow, that's pretty clever, actually.
That's what my government teacher says.
Who, Mrs. Dauber?
No, used to be.
When I took government, if you knew the presidents and if you knew the amendments, you got an A for the year.
That seems
I
so
know
easy.
neither.
All you had to do.
Did you get an A?
Yeah.
Oh, okay.
I already knew the president, so all I had to do was memorize that.
Yeah, wait, who is the 26th president?
26th president specifically?
Specifically.
Washington, Adams, Jefferson, Madison, Monroe, Adams, Jackson, Ewing, Harrison, Tyler, Polk, Fillmore, Pierce, Buchanan, Garfield, Arthur, Cleveland, Harrison, Cleveland, Mackenzie, Roosevelt. Ooh.
All right. First names?
Truman, Eisenhower, Kennedy, Johnson, Nixon, Ford, Carter, Reagan, Bush, Clinton, Bush, Obama, Trump.
Wow, that's impressive.
Wow. I think
Wait, actually, it's
that
Donald.
early teen part is where
Donald?
Yeah, but what's Obama's last
You got me there. Obama and Trump ruined the song. I had a song for it, and then it's like Obama, Trump.
Obama, Trump.
It doesn't ring well. I don't know. Obama, Trump. I don't know. All right. Let's erase that. All right, let's take attendance real quick. Say
I
what?
said, if it makes you feel better, they ruined the country too, not just your song.
Oh, I didn't even hear you say that. I don't want to get involved in any political talk in my classroom. So let's take attendance. Landon, Thomas, Coy, Michael, Andrew, Keegan, Owen, Dylan, Josh, Cole, Nathan, Nick, Caden, Taylor, Aiden, Jake, Matthew, Brady. Awesome. We went through that quick. I should have timed it. All right. Anybody got an answer to my riddle?
We're working on it, so
Wait,
don't tell us.
Oh.
Wait, so is it if you take the letter away, it's permanently gone, or does it come back and then you just remove the letter out?
Did you erase part of the riddle? Is there
No.
space between?
When I tried to memorize it and I wrote it up there, and then I added a word that wasn't in the riddle, so I erased the word I added. Yeah. Is it wheat? It is wheat.
Wait, hold
Wait,
on.
what?
Whoa!
It is wheat. Guys,
Oh my god.
it is wheat. All right. So it is a 5-letter word. If you take away the first letter, it is something you get from the sun. If you remove a second letter, you get something to eat. If you remove a third letter, you get a word you use in pointing at.
Wow.
And if you remove a fourth letter, you get something to drink, which is tea.
At first I said I was going to say sheep, and then I was like, wait a second. I don't think it's spelled that way.
It is. It is. All right. I'm still undefeated.
Pardon the
Yes, we
interruption. Raylan Roberts in the front reception desk.
No. Yeah.
All right. So today, did you guys finish up the video analysis lab we did? Well, it wasn't a lab. It was all the videos we watched about the diver. You tried to?
I think I did. I had to have someone from AP or physics PC or something. Yeah, it didn't go through. I did okay. But that must have been the world's shortest car. I got 160 inches. I got
I have no clue.
I was just looking for it.
I got one.
These two.
Yeah.
Yeah. All right.
How tall was that car? It was a real car.
Yeah. Did I ask
Was it
how
not
tall
an
the car
RC
is? I'm trying to find my answers for it.
I mean, he barely cleared.
You can jump higher.
But I will collect those. I will go over them. All right. But I do want to see how far you guys got.
I want this to be checked. Because I think you helped me and then the next class, just to see if I got the right answer.
You need extra down, but that's fine. But I will go over this. I want to grade them real quick. Get them back to you. I'll be tired. That's all that matters. Thanks, sir.
Wait,
You said a multiplier. Or divide it.
Yeah. Did you stable?
No, I just called it.
Oh, you're a genius. I thought I was stapled. I'm like, I didn't staple.
Yeah, my papers get lost a lot, so I don't pull them.
That's what I'm talking about.
Technically, you can't get rid of.
That's all right. That's all right. We're just checking. All right.
Everything I've been through.
I went through the.
So if you get done throughout class, I'll take it right there. All right. So got a few things, few updates. Collected the video lab. We're going to talk about free fall today. We're going to do a lab tomorrow. We're going to have stations, 4 different stations about free fall. And we'll discuss the lab tomorrow. Quiz on Thursday. Okay. Basically over those 3 equations. You know those 3 equations, you're golden. Actually, you get to use your equation sheet. So as long as you know how to use those 3 equations, you're golden. Okay. You guys are going to do great. I believe in you guys. You guys are doing awesome so far. So lab tomorrow, quiz Thursday. Our first test will be on Tuesday of next week, just to give you a heads up. Day before the birthday? That's good.
Move it back a day.
I don't want to move it back a day.
No, I tried.
All right. So I do want to cover a few things in free fall before we do our lab tomorrow. So I am going to present a few things on your guided notes. If you're looking at the guided notes, we did a walk around activity in the lab stations. You guys remember that? I know most people did not get done with that. So those are good practice problems. As you can see, it's just practice as walking around. I'm not collecting what you guys did because it's on your notes. But if you do have any questions about those problems, I did post a link on Google Classroom, and I went over every single problem. Okay? So if you have any questions on any of the practice problems we did in the back, that was what, Thursday? I think that was Thursday.
Yeah.
I posted a link to Google Classroom. You can find that and answer any of those questions. All right. But we are going to move on to free fall, and we'll get started here. The beginning of this is very simple. Actually, do you want to learn about the discovery of the nucleus?
Yeah. Keep the things to the spoil.
It is genius. And then how they determined the mass of an electron, the oil drop, Millikan's oil drop experiment. Holy smokes. It's like, I don't know. I don't
understand how they came up with this.
Yeah. Genius of what they had. to solve those problems, mind-blowing. All right, so we're gonna start off with the definition, then I got a video for you guys to watch. Super genius. I think I actually mentioned it before. It's the silo they turned into a vacuum. I think I mentioned that. It's pretty cool, actually. All right, so free fall. I think we discussed this before, but it is. Oh, an object is in free fall when it is the only force acting on it is gravity. And actually, what I'm going to do here, give me a second. Got to share my screen here real fast. There we go. An object is in free fall when the only force acting on it is gravity. Okay. Yeah,
So he is not in free.
you are exactly correct. Everybody good? Now I got my silo video coming up. It's pretty legit, honestly. All right, I hope this works. Ah, this is an outrage. I thought I fixed my problem last time. Oh. Yeah. I don't know why I started there. There we go. Cleveland, Ohio. Can you guys hear it all right? Backlight coming up. 3, 2, 1.
Okay, hold on, what was that last part?
Yeah, you lost me at the last part.
I think what he was trying to say was like you have to have a reference point to analyze something's moving. I think is what he was going for there. So like if you're driving behind a car and you are exactly looking directly at that car, it looks like the car is not moving. But if you look at Earth around you, you look at the road, you look at anything else, everything else is going past you. I think that's what he was going for there.
How do they refill that chamber safely?
You just open the door.
I
That'd be like a big explosion.
honestly don't know. I have no idea. Yeah. Say what?
That's physics, right?
Yeah, go.
The mountain goat? I was interested in that that lasagna that popped up here. Yeah, it was like a lasagna ad that popped up like right here. Now, if we do have time, I will show you that because it is pretty awesome. Have you guys anybody seen that video?
It's only 3 minutes.
It's pretty good. I'll show you. We'll get that. We'll get there. All right. So what I want, you guys almost got me there. All right. Oh, there we go. All right. So now we know a little bit of free fall. All right. Why do I have so many tabs open? Come on. Come on. Technology, man.
You could be watching the Go video.
We could be watching the Go video.
Like 16 tabs open at all times.
16?
Only?
Probably. I have 2 different windows.
I mean, that's pretty impressive, honestly.
Well, there's the school window, it's like classroom paradise and all that. Then there's that home window where it's like.
All right. So, let me get my pen ready. All right, we're good to go. Oh, no. All right, we all seen this. We are crushing this chapter. How are you guys feeling about this chapter?
Your enthusiasm is the only thing getting me through this.
But this
Go
chapter,
back. Was that Mario Kart?
yeah, we already did Mario.
I wasn't.
You weren't here for Mario.
All
All right. So, you don't have to write this down. However, all right. An unsupported object falls with the acceleration due to gravity. Gravity falls, right? Everything falls. So that's why it's negative 9.8 meters per second squared. That will always be true. Gravity is just always going to be negative 9.8 meters per second. On Earth.
Okay.
On Earth.
But what is it on the moon?
Negative 4.6 is the number coming to my head.
Doesn't gravity
About half.
change on Earth?
Like, isn't there less gravity?
There's
Different
places
parts.
you go.
It's because Earth isn't a sphere. It's like
What?
It's like a
It's like a football.
It's like a wow. What's the shape called? Oblong, maybe.
Oblong.
Something like that.
No, it's a
So like depends how close you are to the core. So all right. Whenever gravity is the only force, all right, we already talked about that. All right, conceptual. Ball is thrown up. At what point is the ball moving the fastest? All right, if a ball is thrown straight up and coming back down, when is the ball the fastest? Well,
Anytime you throw something straight up, did you just want him to write a line?
so the fastest point is here, but also there.
I thought it wasn't moving. It's right before.
It's moving at both those points. All right. So those are when it's the fastest. Okay. All right. When is it the slowest? Virtually it's stopped, right? Once it doesn't look like it, but when you toss something up, it comes down. So at some point in the air, it has to come down. You were ready. I was impressed.
I was not ready.
All right. Did that. All right. As a ball is thrown up, does it take more time to go up or come down, or is it the same?
It depends on
If
how
it's
hard
depends
you
on-
go.
Wouldn't it be slower to go down? I think it takes more time to go up because it's accelerating.
If it has the same speed here and here, it's equal on both sides, so it takes the exact same time. It's the same.
Apex, the top or highest part of something, especially when forming a point.
But it isn't a point though, it isn't an exact point. There is a point.
That's what you're taking away.
Yeah, that's my point, it's the same thing. I said apex, and you could, retake.
You can really tell it's a Monday.
No, you're good. I was intrigued because I understood what he meant. And
Thank you.
Yeah.
Thank you, Mr. Bowers.
So what if you throw it up faster than 9.8 meters per second? Wouldn't it be faster than going up?
if you throw it up faster,
Wouldn't it take less time to go up? If you throw it up faster than 9.8 meters per second?
so it's actually going to go like that, right?
Yeah, what if you threw
But
it
then
up
you're
and
actually
velocity?
eventually going to have to still come down.
But wouldn't
What
that
if
be
you
nine
throw it
point eight?
into outer
But
space?
that's.
If you throw it into outer space, then it's never going. It's going to go like. Actually, it's going to have some curve to it because it's going to be attracted to something in outer space. Oh, it's going to be some type of curve, like because it's going to be pulled towards something.
All right, I have a question. So the only argument I have for this is if you throw a baseball 90 miles per hour up there, it won't come down at 90 miles per hour, will it?
No.
Yeah.
Well,
So then,
Not until the end.
not till the end.
Wait, but hold on, I have.
but how will it reach 90 miles per hour?
Because it's decelerated.
Because you're
Yeah,
you're
that's
still
my
going
question.
down. So whatever acceleration you come up, whatever acceleration is going up, you come to a stop. That acceleration is going to be coming down. So no matter how fast you throw it, like I showed here, it's going to be steeper. It's going to go higher. But eventually it's going to still have to come down, and that acceleration is going to equal that point at the bottom.
Okay, so what if you throw it up faster than the terminal velocity of said object, and when it comes back down, it can only reach terminal velocity?
He's got a point. That's the point. That's what everybody's been trying to ask.
That's the. So if you're throwing it up at terminal velocity,
Yeah.
man, I did not think I was going to spend this much time on one slide. So if you throw it up,
Don't you want us asking questions?
say that one more time. If you throw it up
faster than the object's terminal velocity, because it's different like for every object, right? Depending on like the shape and the mass. So if you throw it up faster than said object's terminal velocity, when it comes back down, it could only reach terminal velocity.
So that's statement or a question?
Yeah, I think that would take like, you know.
I don't-
It's a question, like I'm proving you wrong, right? Because you're saying both sides should be wrong.
I'm gonna look this up.
Okay.
I'll
No,
Might-
if for me, because he's saying that both sides should be equal, and I'm saying, but they cannot be.
It's time to stop.
No.
I want my goat time after this.
Oh, I gotta go. I'll stop talking. I'll stop.
No, assume there is no wind there.
There's no way.
All right. I'm gonna look that up. I'm gonna ask the physics gods tonight, and I'll let you know what they say. All right. All right. So this is one of my examples. All right. Example of ball being thrown up and down. All right. With the times. All right. So if you're throwing it up 5 meters per second. All right. All right. And then at some point you're going to have 3 meters per second. And at the very apex spot, you're going to have 0 meters per second. All right. But coming down, it's going to be the opposite. You're going to be at -3 meters per second, -5 meters per second. Now, when that reaches terminal velocity, I'm going to have to look it up. Yeah.
Okay, so if you were to launch something at like 2,000 feet per second, straight up, assuming no earth rotating, no wind, just air resistance and gravity.
Yeah.
At this rate, we're gonna push the test back and say it gets to an altitude of say 400. But yeah. Would it reach 2,000 feet per second on the way down?
At the very bottom, like when it hits Earth, yes. Like if you launched it at that speed, it's gonna hit Earth at that speed.
What if it changes shape? Well,
If it changes shape, then air resistance plays a factor. And I'm actually getting an idea for your question. I don't have it full yet, but I'm getting an idea.
Mr. Mallard.
Well, can I go? Yeah.
Please.
What you got?
Will the time of the vertex always be faster than the time?
Yeah.
Unless it's terminal velocity.
It's a great observation. That is a great observation. So this is half the time. This is full time. Right? All right, we're going to move on. All right, so concept question. If I throw a ball downward, I am shocked that didn't hit the ceiling. If I threw a ball downward, would the acceleration be greater than -9.8 meters per second? Or less than it should be -9.8 meters per second.
Be greater. Because you have the initial force plus the.
How many people say greater?
I mean, it depends on how technically you get, because it's going faster now.
It depends on if you throw it at terminal velocity.
How
or
many
not.
people say less?
It's going faster.
All you have to do is drop it.
How many people thought this was a trick question? You are exactly correct. Gravity is negative 9.8 meters per second. It does not change.
Wait, what?
Gravity doesn't change. Negative 9.8 meters per second squared.
with the.
But you didn't say squared, you said it's moving faster than 9.8 meters per second.
Squared.
No, but you have.
Paper says square.
Wait a second. Can I see that?
Square, it's on the paper.
Okay, so if I drop this,
For the first second, it's dropping 9.8 meters per second. For the second second, it's dropping 19.6 meters per second. For the third second, it's dropping 29 point. I don't want to do that in my head.
yeah. All right, I'll give up.
Throwing.
It's 90.
So gravity, anything that
Can we
drops,
just watch the go video?
anything that drops is negative 9.8 meters per second.
This wasn't a good idea.
That's the acceleration.
But it's just.
Oh, I see.
So what? All right. Now, if I throw a ball up, is it initially trapped? If I throw a ball up while the ball is initially traveling up, is the acceleration positive going up or is it negative?
Negative.
Wait, but what does it say on the example of ball going up and down? Why do you have it as 3 meters per second? And on the way back down, negative.
Because it.
Oh, wait, that's not acceleration. Never mind.
I don't like this.
What is the acceleration? Is it going to be positive or negative? Going while it's going up.
Positive.
Gravity is negative 9.8 meters per second. What is the acceleration?
Negative.
Negative. Gravity doesn't change. It's negative 9.8 meters per second. It's still falling. Like it's going up, but acceleration is pulling it down. So it's negative. What? Yeah.
It's just falling up.
Forces of acceleration.
Hey, if you go to the other side of the earth, like in China. there's-
Yeah, see if you put a.
So you can have an initial acceleration, like an initial force, but after you do that, the acceleration is always negative.
Like, I mean, if it's traveling up and then it starts to move faster up, but you throw it, then
That's why you-
there'd be some kind of acceleration that's also goes down. Or
China doesn't
always
exist.
down.
always down.
Now you can have an acceleration going side to side,
Okay.
but it's still going to be negative. It's like that one experiment where it's the guy, have you seen where he rolls a ball off the table and he drops the ball at the same time? What do you think would fall first, the ball that's rolling that way or a ball that's dropped the same?
They're probably landed at the same
They
time.
land.
They're always going.
No.
Even though the ball that rolled went
Neil
off.
deGrasse is
My mind is.
Neil deGrasse Tyson
so.
said,
You took a golf.
hey, like, can you made the earth the size of a ping pong ball, it would be smoother than any ball.
Positive going forward, but you can't go positive going up.
So acceleration is always negative 9.8.
Going down. Like if anything
I'm
falling,
just saying hypothetically.
anything in the air is gonna fall at negative 9.8.
But if you,
Guys, fight down real quick. Because it's still slowing down. It's kind of like the car example. So if I have my car, I can still be traveling forward, but if I have my brakes on, my acceleration, so my velocity, I'm still going forward, but my acceleration, I am slowing down. Yeah.
Okay, so what you were using as an example earlier, so if you were to launch a bullet
All right.
Yes, they did this experiment.
and drop one.
Yep.
Of the same mass.
Yep.
They both hit the same.
Exactly. I didn't feel like saying that example just because like teachers going that.
You can put on a list.
That's why they do a ball experiment. But they have done that before.
You're saying a bullet.
How do they time it though? Precisely.
I don't know, honestly.
Cool.
Alright, can we move on to slide 4?
Yeah, slide 4. Oh no, we're not done with this one. At the very top of a ball's motion, so at the very top, is the acceleration positive, negative, or 0?
0.
Negative 9.8 meters per second squared. Everything's falling at negative 9.8 meters per second squared.
Yeah.
It's the answer for all three of those.
So, but is the Earth traveling?
So what you're saying is gravity acceleration is always
Through the
the
object.
There we go.
Why didn't you just say so?
So technically,
I
we're
did
all
good.
accelerating.
I'm kidding.
Negative 9.8.
And yeah,
Okay.
and that's why when you walk, like, you pull down, I feel like.
Why is it gonna raise my finger?
Now, when you ride on like an elevator, there's a reason, but when you're riding down on an elevator, we're not getting to this part yet. We'll get there. No, it's not yet.
It's still 9.8.
It's still negative 9.8 meters, you're being pulled down, but since the elevator's going down, you feel lighter, right? You feel like the ground, I don't know. how you describe it.
Yeah, I would-
Like, it's
The water in the bowl.
your pull being down is less, but it's still negative 9.8, but it feels less. Because you're traveling in the same direction. So your velocity going down is with your acceleration going down.
So right now, I have velocity negative 9.8, correct?
You have an acceleration.
Oh, no, yeah, sorry.
Correct.
Okay, so if you drill a hole all the way through the earth and like drop like our golf ball inside,
Yeah.
like would it go out the other end or would it start like, coming back?
No, it would go
I'm
back
asking
to-
Mr. Bowers.
So, with
Fine,
no,
we can make the hole in there.
with no air resistance,
Yes,
like a vacuum.
yes.
So here's your core, here's your like inner core, here's, I don't know all those things, right? So if you drilled a hole like that,
Yes, like that, like in China.
and you drilled it straight through this.
Yes, ignoring the fact that it's molten metal, but like,
I think
First
if
of all,
you like put a tube in it, then like, you know, like keep the metal out.
What are you talking about?
We dropped the ball from this side to this side.
Of Earth?
Yeah.
Okay, I actually read about this.
I actually
did
heard
read about this.
Yeah.
You got an actual answer?
I think, so you would go back to the center and then you wouldn't know what's back, so there's probably 50-50 chance to go this way, or you go back up and keep going this infinitely.
Yeah, Brian Green literally said.
Pretty
that.
genius.
Yeah.
But you could go through and back and forth.
Yes, you don't, I don't know the exact answer, but I'm 90% sure that's what
I think you go through.
happened. Well, because the gravity is changed once you get in there.
It's your acceleration.
That is true. You're like at the center.
Yeah, so if you're going back up or back down, that's the same, because you wouldn't know how the gravity is just different. I don't know how to explain it. I don't know the specifics.
You'd still have inertia though. in
Yeah,
that
she gets what I'm
direction.
saying. So like my idea is like a big like spaceship sized hole.
So Harry
You
Yeah.
can shoot a rocket through the earth.
Yeah, Harry and Cindy go to New York to the other side of the
Space
building
shuttle,
and
like, use the gravity of Earth
and
and get
climb
out
to the top.
using
When they
those-
get to the top, Cindy decides to drop a penny to make a wish. How long does
Didn't
it
they do
take
that
to
in Total Recall?
I don't remember any of that movie.
That's the Arnold Schwarzenegger one, right?
You don't totally recall it.
There's also
Ha! You're funny.
I don't know. That's just a very odd question. On the center of Earth. All right. I've never been asked what happens if you drill a hole through the center of Earth before.
I'm looking at us now.
I think
So, it's a
Literally how, okay, you would fall through it, but you don't know how the gravity would react.
Yeah, it would like get put in.
All right. So let's try a practice problem here. Let's try a practice. All right. Now, let's see. Harry and Cindy. Let's get back to, I miss Harry and Cindy. They're my friends, you know. I can talk to. All right, Harry and Cindy decide to go to New York together. They decide to visit the Empire State Building and climb to the top, 380 meters. All right, so I know my displacement, 380 meters. Okay, just writing down my numbers I got, right? All right. Let's see. When they get to the top, Cindy decides to drop a penny to make a wish. It's a great idea, right? How long does the penny take to reach the ground? All right. So she's actually dropping the penny. So what's our displacement? Positive or negative? Negative 380 meters. All right. What is acceleration? That's what I'm talking about. Negative 9.8.
Yeah, that's my thing.
All right. Now, I have one other piece of information that I know. All right. I know my initial velocity. 0, right? My initial velocity is 0. All right. And it's asking for time. All right. Once again, I'm using my equation sheet. Okay. Let's see what we got. Oh, I wrote on that one. Let's see what we got here. I'm going to zoom in. Wrong side. There we go. All right. I have x, a, initial velocity, and I'm solving for t. All right. Let's see. What equation do I want to use? Probably the second one, huh? Because I don't know my final velocity. I'm going to use this equation. Because I know my delta x, I know my initial velocity, I know I'm solving for time, and I have my acceleration time squared. All right. So here we go. Delta x. Now, a little preview. The equation says x is equal to x initial plus v initial time plus half a t squared, right? Oh, I'm sorry. So it says that. Now, whenever I write this, I always put delta x because delta x is final minus initial. It's kind of like I just take that to the other side. Does that make sense? It's how I like to write this equation. It kind of saves a step. So then delta x is equal to initial velocity times time plus half acceleration times time squared. Does that kind of make sense? Just saves a step in the formula process. You know what I'm saying? All right. Now, I have my delta x. All right. It drops negative 380 meters. Let me zoom in a little bit so you guys can see that a little bit better. It drops negative 380 meters. Equals, what's my initial velocity? 0. 0 times time is still 0. Is that our bell?
Yeah.
Holy smokes.
Dude, we talked for this was like 15 minutes.
All right. I completely lost track of time. Sorry, guys. We'll get to the Go video tomorrow.
I can't. Wait, where's the cow?
The answer is
Where's the cow?
8.8. Yep.
Where's the cow?
Fire hydrant.
Are you kidding? Oh my god.
The final velocity is 86.
Oh, wow. Mr. Bowers, that is not a fire hydrant.
Fire extinguisher. You guys are playing with my brain today, honestly.
Like, I have one not actually crazy question.
Yeah.
What if she wished for the penny to drop?
If you have your acceleration at 9.8 meters per second squared, like using gravity, does that mean your displacement also has to be in meters to match that? Do units have to match up in those?
Yes.
Yes.
That always has to be meters. Velocity is always going to be meters per second.
So like if they put the building height P, would you have to convert that to meters to put in the equation? Okay.
Yes. That's a great question. Yeah.
Excellent. Thank you.